Hello and welcome everyone. In this video we'll be integrating square root of x over 1 minus x dx. Square root of x over 1 minus x dx. To integrate such kind of square root function, there will be different technique, but this time we will not directly apply those techniques. We have to approach this kind of integral systematically. So we can write it, we can decompose the given square root and write it as square root of x over square root of 1 minus x dx, and then rationalize the numerator, not the denominator. Rationalize the numerator. That means let us remove the dx and multiply with root x over root x dx. It's going to be the integral root x times x, it is x over, the denominator will be x minus x square. Somehow interesting now, as you see. At least there will be a substitution technique, and this time we can apply. So at this point we can say u is equal to x minus x square. Then du is equal to the derivative of the right side will be 1 minus 2x dx. As you see here, there is x at least, but it's not only x, 1 minus 2x. There is no 1 minus 2x here. But we can multiply both of them by 2. So when you multiply by 2, the integral will be 2x over 2 square root of x minus x square dx. It can be written. Now we have 2x, but we don't have still 1 minus 2x. But we can write the 2x, it can be written as 1 minus 2x. We can write it. 2x, it can be written in this form. So in place of 2x, we can substitute everything what we have here. So it will be the integral 1 minus 2x, the whole over 2 the square root of x minus x square dx. Then we can separate 1 over this thing minus the remaining part. Okay, let us go to the next page. Therefore we have 1 minus 2x, the whole over 2 square root of x minus x square. Already we said u is equal to x minus x square and du is equal to 1 minus 2x dx. Already we have this one in our previous substitution, but we are not completing it. 1 minus 2x dx. Therefore when we decompose this one, it's going to be the integral, just there is dx here. Now when you separate, it's going to be dx over 2 square root of x minus x square, we have, minus the integral 1 minus 2x, the whole over 2 square root of 1 minus x square dx we have. Now let's deal one by one. Let's come back here first. This one, the whole, I think will be substituted already. This is the upper part. Everything will be substituted by du here. We said it already. This is dx. So it will be du over 2 square root of u. Because the whole thing in the square root, we said it already by u. We have this integral to the right side. But remember, radical u, when you derivate it, it will be 1 over 2 root u. Okay, let's do it down. Radical u, if you try to derivate it, it will be 1 over 2 radical u. Therefore, the whole integral, it will be written root u plus some constant c. But what's u? Let's get it back, the u. It will be the square root of x minus x square plus c1. Why c1? Because when you integrate the other part also, there will be another constant. At last we'll take together. Now we integrate only this part, what you see here, minus this thing will be continue. Now let's get back to the first integral. Okay, let's use again another page. Okay, so that we stopped on the integral 1 minus dx over the square root of 2x minus x square minus the integral 1 minus 2x over 2 square root of x minus x square dx. We stopped here and we got already this result. This result will be the square root of x minus x square plus c1 already we said. So let's get back and deal with this one again. Let's go another page. So the integral dx over 2 square root of x minus x square. This is what we are looking for now. This one again, to integrate, we don't have another technique, but we need to separate the denominator now. The integral dx over 2 root x times root 1 minus x. Like the first one, x is taken out as a common and separated. Now this time we can say u is equal to square root of x, and du will be, the integral of this will be 1 over 2 root x. So dx over 2 root x. Now at this point again, try to focus. This is the whole thing. What you see here, it can be substituted by du. But we didn't substitute this part. Okay. To do that, again, u is equal to square root of x. Square both sides, so u square will be just x. Then we need 1 minus x, so 1 minus both sides. So when you do that one, 1 minus u square is equal to 1 minus x, and put in the square of both sides. Square root of 1 minus u square will be square root of 1 minus x. What did I do here? We need to be focused. This question is somehow challenging. Remember, first of all, we said the radical x will be u. Then when you derive, I got dx over 2 root x, because radical x derivative is 1 over 2 root x. Then the whole thing is substituted by du. Okay, we have got relief here. But square root of 1 minus x is not substituted. To do that, once u is equal to root x, if you square both sides, u square will be x. And if you make 1 minus both sides, 1 minus x will be 1 minus u square. For both sides, we did 1 minus here. Then put in the square root both sides again, because our objective is to substitute 1 minus x in the radical by this result. So this integral will be, let's change the color. The integral, remember, the whole thing is du, and the remaining part, this part is 1 minus u square. 1 minus u square. Now the integral of this result, it is sine inverse of x. We need to recall that. This result will be sine inverse of u plus c. That's what u, it's radical x. So the result will be sine inverse of root x plus c2. This is constant, we can say. Therefore, we have everything now. Sine inverse of root x. So when you get back and finalize now, this part integral, we got it sine inverse of root x minus this part integral is here, it is square root of x minus x square plus c. And this will be the end of my video, and that is the integral of x over 1 minus x, the whole in the square root dx. This integral result will be this one. Thank you for watching.